We start first with some fundamental things. Okay, we have basic proposition, logical connective, equivalent, blah, blah, blah. And I try to cover proposition first. Okay. What is a proposition? English has so many statements. We can have many statements. I like UMP. I hate UMP. Maybe you can say I hate HEP because they don't return our fee. Yeah, that is a statement. But not all statements are proposition. A proposition must be a declarative sentence that can be answered either true or false, but it cannot be both. That is a proposition. A statement, okay, blah, blah, blah. Okay, so a proposition must be true or false, but not both. Let's look at some example. Just now, I say a statement, I like UMP. Can it be answered as true or false? You answer yourself. I like UMP. That kind of statement, you can answer true. Yeah, true. I like UMP. Or you can say false. No, I don't like UMP. All right? So these are some of the examples that is quite obvious. Okay, this slide is not mine. By the way, they have answers inside there, but that's fine. Ask yourself again, yeah? I love DMA. I love mathematics, discrete mathematics and application subject very much. True or false? As it can be answered by either true or false, then it is a proposition. Okay? We have to drink 8 glasses of plain water every day. Yeah. True for some, false for some. But let's look at how are you today? For example, if I ask my student, how are you today? You don't definitely answer, yeah, true. How are you today? True. That is very wrong. You don't answer, how are you today by true. You answer, how are you today? Yeah, fine, sir. Thank you. And how do you do, sir? Yeah, I'm also fine. I'm not doing that fine. Okay, that kind of statement is not a proposition. Okay, very simple. It can be answered by true or false. Look at this one. Answer it on your own. You can say it loudly if you want to. Try to look at 3.1, exercise 3.1. Which one are propositions and which one are not? Okay, fairly easy. Wait, I need to open Microsoft Whiteboard. Ya. Oh, ada lagi nak join. Okay. Whiteboard. Yeah, this one is better, I suppose. That's nice. Okay. No pets are allowed. Is it a proposition? No. No pets are allowed. We cannot answer that by using true or false. So it's not a proposition. What is your name? It's not a proposition. I am proud to be a Malaysian. That one is a proposition. It can be either true or false. Okay. We proceed with the next part, logical connective. While I'm waiting for this to on. Wait. Okay. Usually, a proposition can be altered proposition. For example, just now, I am proud to be a Malaysian. We can alter this statement D by using some kind of what we call as logical connectives. There are several logical connectives. Okay. Some of them, I start first. I cuba conteng sekejap. Sekejap, siapa ni? So, how you make your background like that? Background apa? Farhan ni mana? Ayah. Tunjuk muka lah Farhan, kalau orang ni. So, how you make background apa? I don't understand your question and it's not relevant. I don't want to answer yet. Okay, bye. Okay. No. Okay. I will do some table. Okay. For example, I start first with the okay, testing, conteng. Okay. We have not and or if blah 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 blah, then if and only if. Tak detect. If and only if. Okay. Detect pun. Okay, these are some of the logical connectives. Okay, we have 5 that will be covered in this course. Okay, for example, just now, apa soalannya? I love to be Malaysian. For example. Okay, this is one proposition. Let's say I define it as P. Proposition P, I love to be Malaysian. I put one more. I put one more. Apa dia? Nora. I don't know who. Nora is cute. Nora. Okay. Nora is cute is a proposition as well as it can be true and it can be false. P and Q is called as logical variables. We can represent it as a P and Q to make it short. For example, I don't want to use this example. You can explore it also on your own. For example, if I have a apa ni? Oh, ni yang lama ni ya. Ada lagi nak masuk? Okay. Sekejap saya padam yang lama. Okay, share it. Back. Okay. For example, if I want to say, I love, betul ke statement? I love to be, I'm proud lah, I'm proud. Tak apalah. I love to be Malaysian. And, for example, I want to connect this P and Q. I love to be Malaysian and Nora is cute. So, this and become our logical connective. See how we connect two propositions together. I love to be Malaysian and Nora is cute. And we can change this compound proposition. The single proposition, we call it atomic. If it have we have more. We have more that is combined by using logical connectives. So we call it as a compound proposition. Very easy. If I want to change this into notation of logic, I love to be Malaysian and Nora is Q. So there are some symbols. Forgive my handwriting. I'm trying my best to write as clear as I can. Note, the symbol is this. Ini. You can use the left one or the right one. And inverted hat, we call this is hat symbol, or is inverted if arrow, if and ada lagi nak masuk admit, okay. If and only if is double arrow. Okay. If I want to combine I love to be Malaysian and Nora is cute, then it can be simply stated as P and Q. Very easy. Very easy. And the skill to change the English sentence into logical representation is needed. The skill to change from English to logic symbol. Okay, that is very needed. Let's proceed with the next example. Ayo, ini hari tu punya. Dia auto save. Okay, Microsoft Whiteboard is good. They don't delete. Very easy. Padam. I want to padam. Okay. Okay. Just now is English to logic, a word. Why not I test you? What is the meaning of this? This is example 1, example 2. If I put not Q and I want you to change it into English statement, what will it be? Farhan, apa akan jadi? Mana suara Farhan? Can I hear your voice, Farhan? Come on, Farhan. Or Iqbal, please. What is the meaning of not Q? In this case, where P is I love to be Malaysian, Q is Nora is Q. My problem, ya ke ni? Okay, tak apa. What is not Q? My question right now, what is not Q? Anyone? Come on, don't make me so lonely here. It's lonely in my office. It's so lonely. Please, could I hear some voice? No, please.
Hello, sir.
Yeah, what will be not Q, Praveen?
Nora is not cute.
Nora is not Q. Who is Nora, by the way?
Huh?
Who is Nora?
Who is Nora?
Do you know Nora?
Don't know.
No. Okay, right. Thank you so much, Praveen. Nora is not cute. Okay. Nora Ellen. Okay, Nora is not cute. Very good. Very easy. But please, although it's the answer is fairly easy, some of my students will do some mistakes because they are being negligent. They are not careful. What happened here? Wait a minute. I delete this. My old works. I don't want to clear canvas yet. Okay. So Nora is not cute. When you want to transfer it, make sure the words in the logical connectives column must be there. Nora is not cute. Proceed to the next question. What is P implies Q. Okay, later we will go very deeply into one by one. But again, if I want to change it into an English statement, then it will be if I love to be Malaysian. I put then there, then Nora is cute. Okay, for example 3, some of you might asking me this, why, what is the meaning of this? This word does not make any sense. Bear in mind, logic field, it does not state that whether this statement is correct or not, different. They just evaluate whether that argument can be used. So this kind of representation, if I love Malaysian, then Nora is cute. It's still considered as they obey the logic rule. We can use this kind of example. But in the practical world, there is no relation. Why I love to be Malaysian, then Nora is cute? There is no such thing, maybe. All right, we proceed with the next one, where I clear my canvas. Clear canvas. So slow. What happened? What happened? Yeah, it's jammed. The whiteboard is jammed. Okay, clear canvas. Okay, we proceed with the next one, which is known as truth table. So get started, everyone. Try to prepare your pen or pencil with some blank paper. We will do some truth table today. Sir, not symbol is no. Okay, Farhan tanya. Not symbol is this. Maybe I don't write it clearly. Symbol is ayo. This is not symbol. Or you can use this. This is not symbol. You can use either one. Okay. Okay. Clear, Farhan? Proceed with truth table. Okay, we have 5. Just now I said we have negation, conjunction, disjunction, conditional, and biconditional. I will write it back because there is order of precedence. Most of you know about board mass. Board mass. Malaysia, we use board mass. For our international friend, the board mass means that we do the bracket first. In any arithmetic operation, we do bracket first. That is the priority. The order. Then we do division, multiplication, addition, and lastly, subtraction. So that's why when you see, if I put, for example, what is 2 plus 3 times 5? Okay. If you are doing 2 plus 3 first, then you are wrong in terms of arithmetic operation. You need to do 3 times 5 first, which is 15. Then you add up, comes 17. There is some certain rule. This is rule of board mass. Why I mention this? Because we have rule of logical connectives. Okay, logical connectives just now. Ayo. Wait, yeah. We have not and or. If then. if and only if. Okay. The symbol, not, and, or, arrow, if and only if. Okay. This is the order of precedence. You must do not first. Not is the highest priority. Negation. Not is negation. And conjunction. Disjunction or implication or conditional is fourth. And biconditional is the least important that you need to do. Not least important, I want to say the last priority that when you want to combine the logical operation. All right. Symbol. This is logical connectives. Symbol. This one is order. Order of precedence is now. I think that should be it. Very simple. We start first with the negation. Negation is the simplest one. Today is sunny day. So lagi P. Today is sunny. The negation of P. Silap. Okay, use the same example. We start first with the negation. Not P. What will be the English sentence for P, not P? If P is today sunny, so not P will be today. You must take some logical connective from the top. Is not sunny. Very easy. The negation. Let me put some mathematic example. Q. Q, for example, if I put like this, 2 plus 3 equals to 1. Oh, okay, some of you, what is this? 2 plus 3 is not 1. Okay, don't really focus on the logic again. Don't focus on the truthness of the equation. Logic does not measure the correctness. The correctness must be used by the skill of proving method chapter 4. Okay, 2 plus 3 equals to 1. What is not Q in this case? You can say 2 plus 3 is not 1. Or you can say it very simply as 2 plus 3 is not equal to 1. This is the negation of Q. Two ways of represent. You can say 2 plus 3 is not 1, or you can say 2 plus 3 is not equal to 1. Okay, that's enough for the example of negation. Okay, I will clear my canvas here, so make sure this one you already memorize. Copy it somewhere. Okay. Okay, if you look on the left here, truth table, there are certain rules here. SP and not P. Hey, what happened? Oh, okay. Okay. P, not P. As proposition can be either true or false. If it involves one proposition P, then we have only two possible combination. P, true or false. The negation of P is F, and the negation of F is P. Very simple. This is the law. You cannot change the law. The judge can change, the lawyer can change, but the law never change. This is the negation. All right. We proceed with conjunction or and. Conjunction, right now, if you want to combine, you must have two propositions. Today is sunny, or Q, I bring an umbrella. That's why P and Q, today is sunny day and I bring an umbrella to school. Very easy. And there are certain rules pertaining to this, which is, okay, just now we have only one proposition for the negation case. Right now we have two propositions. If you involve two propositions, the fundamental thing is that how many combinations can be made. I have PQ here. P can be either be true and can be either be false, but certain combination Q, if P is T, Q can be T. P is T, Q can be false. Other possible combination. So the standard rule of thumb on how to construct your initial column, it is based on 2 to the power of n again, like the formula of power set. This time n is number of proposition. So for example, on the left one, okay, we have only one proposition. So 2 to the power of 1, you have 2 rows. Okay, for the bottom part here, how many rows that you can have? Because you have 2 proposition, P and Q, 2 to the power of 2 is 4 rows. Like the left. So what will be, how many rows will be if we involve 3 proposition? Regardless of the operation. How many rows first? The initial row. We don't start doing anything yet in terms of the construction of truth table. But how many combination of P, Q, and R? And some of you might answer it already. We have 8 rows. And this is how I want to teach you on to do this easily. And I hope you will use the same structure, because different structure will get a different arrangement of the answers. P 4 times, false also 4 times. T, F. Q, T 2 times, F 2 times. Alternately, T 2 times, F 2 times. And R, very easy, EF. Very easy. All right. So we have 8 rows, regardless of the operation. We go back to the conjunction part. N, P and Q. T and T is T, T and F is F. F and T is F, and lastly F and F is F. Okay, any question for the time being? I hope not. It's still simple actually. Because we don't construct the table yet. Okay. Okay. This junction is OR. Again, I will not touch this very long because it is just a rule. For P or Q, only when both of them is F and F will result in F. Otherwise, true. Okay, this one is tricky. A little bit. Where I want to highlight this one. Slowly. Oh, okay. Okay. PQ. Please pay attention. P implies Q. Okay. T, T, F, F, T, F, T, F. And by this rule, T, 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 F is F, F, T, T, F, F, T. What I want to highlight here is that implication is very direction sensitive. It is very direction sensitive. P implies Q. Q implies P. It's not the same anymore. Okay, look carefully. Q implies P. T, this time being at the front. T implies T, conclusion on the left. So it will be T. This one, the second row right now, F implies T. If F implies T, F at the front, the conclusion is T. So F implies T will be T. Look, it is different right now. Color line, color line. It is different right now. The answer, because it must happen at what? At the front first. Okay, for the third row, T implies F is F. And lastly, F implies F is T. So this is a good indication. The P implies Q is T, F, T. The Q implies P is T, T, F, T. And this is obvious, huh? P implies Q is not the same with Q implies P. Implication is very direction sensitive. Yeah, I use this term. Beware. This is the common mistake. Always this mistake that the student don't realize which comes first. Which one is the condition? Which one is the conclusion? P implies Q. This P is the condition. This is the conclusion. For the third column here is changed already. Q is the condition, P is the conclusion. Any question? Any question in 1 minute? I want to drink some water. Okay. We shall proceed with the next one. Okay, this one I skip first for the next lecture. Maybe we still have time. By the way, the video for logic is not made by me, it's made by Miss Anis because she's my colleague. I need to give her some work also. So just look at her video and also listen to my online lecture, okay? This one skip first. I also don't hear her lecture yet. Directly I go to biconditional first because this is a law. Biconditional. Okay, biconditional. Only when both of them have the same truth value, okay, P, if and only if Q. Again, standard TTFF. TF, TF. Only when both of them have the same true value. For the example, the first row, it will be T, and his will be T. FF, they have the same true value. Otherwise, false. Very easy. How about Q implies P? Sorry, Q if and only if P. In this manner, it does not change. T, F, F, T. Okay. This is the law. And I also happen wants to tell you that P if and only if Q, it is equivalent with P implies Q and Q out. Q implies P. It happens at both directions. Later we will try to prove this, maybe in the next lecture. We proceed. We've tried to develop our first truth table. Okay, we only do a few examples today. For example, like this one. Given a compound proposition, blah, 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 not Q and P, if and only if not P or Q, find the true value. Okay, we will start constructing the truth table right now. Do it on your own, together with me. P, Q. Previously, when you get this question, this table is not given to you. It's empty, it's a blank spaces. You need to construct this on your own. The first step is that you must check how many statements are there, how many propositions are there. As it will only involve two propositions, then you will have, sekejap, bateri nak habis. Bateri. Bateri handphone nak habis. Yeah. Okay. Okay, PQ. You have two propositions. So P PPFF PF PF. Next, the question not Q and P if and only if not P or Q. Okay. When you look at this compound proposition, a long one, not Q and P, we do what's in the bracket first. Bracket first. So in this particular bracket, this one, you do which one first? You do the not first or the and first? Okay, if you remember from my previous one, oh, thank you, Amir. Yeah, it's not first. You do the not Q first. You cannot do, don't do this, If you start with Q and P first, you will be wrong. You will get the wrong answer at the end. So please do not Q first. Okay. Now we play with the table. The negation of P is F. Yeah. Black color, please. Black. Okay. Ayo. Wait, It's very close to this. Okay. Okay. The negation of P is F. The negation of F is P. The negation of P is F. The negation of F is P. Then we proceed with not Q and P. Not Q is FT, FT. What is, okay, when we look at not Q and P, you only focus on P and also not Q. Don't look at another column. Focus on one column at each time. So not Q and P, F and T, if you recall from the previous law, F and T is F. T and T is T. F and S is F. And T and F is F. That is how you do it. We finish this part. This part settled. It means that the first bracket has been done. Then, when you look at your right, it is if and only if, biconditional. We should skip this one first because that is the last priority. So we skip this one first, we proceed to this bracket. And again, this bracket, you have not and you have or. Which one to do first? Again, not. Not is number one. So we focus on this bracket. You should do not P first, kurungan, garis. When you look not P, you focus on the P. So the negation of T is F. F. The negation of F is T. T. Done. And you proceed to not P or Q. Not P or Q. TF is T. FF is F. TT is T. TF is T. Done. We finish the second bracket. And lastly, we proceed to the combination of all. Not Q and P. If and only if not P or Q. We focus on this and also this column only. And look at the law of biconditional. F and T is F. T and F is F. F and T is F. And F and T is F. Okay, is there answer to this? No, no answer. Huh? Okay, check. Is there any operation that we did not cover for this? All of them has been done as far as I am concerned. Then if everything is okay, then you should be fine. Just a few tips. Huh? Before you proceed, okay, just want we start with the initial one. Huh? This is the initial column. When you move to the right to develop the next column, make sure you do the next column right, correct first. So let's now I want to check. Not Q. I do not Q first. F T F T. So this one is correct. Then I proceed. Double check or triple check your answer before you create another column. Not Q and P. F T F, T T T, F F F, T F F. Correct. Then you proceed. F F T T. Okay. Then you proceed to the next one. Not P or Q. T F T, F F F, T T T, F T T. Then you proceed. Okay. F T, F T F, T F F, F T F, F T F. Okay. This tips is very good. Before you proceed to the next column, you must do the column right first. Because if not correct, your mistake will be tracked back until the end. Every mark is given usually by each column. This one is 1 mark, 1 mark, 1 mark, 1 mark, 1 mark, 1 mark. If you do one column wrong, for example, if I do the wrong column and not Q here, for example, that it will be dragged down up until to the right. So make sure, again, I say for the last time, make sure do each column right before you create another column. All right. We do last example before we end the lecture today. Before we end the lecture today, we do one more example. We do the first one first. A. Okay, do this. Not Q or P. What is the first step? Check how many proposition you have. 2. Then you have T, T, F, F, T, F, T, F. P and Q. No alteration. No combined operation is there. So we do P and Q directly. T and T is T. F, F, F. Next, you do the next bracket where you happen to need to do not Q first. F, F, T, T. Not Q or P. Focus on this. Focus on this. F, T, 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 and T. Finish. Oh, tak finish lagi. Lastly, you combine P and Q or not Q or P. Where you need to focus on this one or this one, okay? I double check. F, T, 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 T. Okay. Lastly, T or T, T. T or F, T. T or F, T. T or F, T. Okay, double check my answer because I'm not seeing this clearly. My handwriting is not good at my laptop. Okay, I give you 1 minute to do B, and I want someone to show me the answer. Do B right now. If still only 2 proposition, do this right now, and I want to see the answer. You don't need to show your face. I would just want to see your answer. No one wants to see your face, by the way. I want to see your answer for B. Do B, please. Come on. My battery is nearly finished. Yeah. What happened? Okay, B, I just write the question, not P or Q, if and only if Q implies P. Okay. 1 minute, guys. The good thing about this online Google Meet, I can see all of your name. And I can see some of the face if you put the face. Oh, ini dia Muhammad Farhan. Baru nampak muka. Nurul Anissa Mazalan. Muka kucing. Saiful Azani. Raja Tanison. I can see your face. Oh ya, Nurul Anissa. Ya, muka kucing mana saya tahu. Ni Muhammad Iqbal. Lagilah Pokemon. Apa? Okay, Nurul Anissa cepat jawab. Okay, answer quickly. Balni. Apa ni? Typo right? Balni. Yongjan Lee. Chian Kian Fei. Okay, Anawin saya ingat. Muka dia. Adam Pang. Who is Adam Pang? Adam Pang. Letak gambar akhir. Okay, Yong, please answer as well. I'm waiting for you guys answer. Okay, Habiballah is also there. Okay, carry on. Abdullah Babutain. Abdullah Abu Bakar. On the way. Okay, I'm waiting for you. All right. Because I want to see my students answer. It's important because, like I mentioned in the WhatsApp group, it's not important that I can answer. It's more important that my students can answer. That's why I like to see my students answer. To see that they can apply back what I taught. And you should be lucky. Logic is the easiest chapter. Make sure everyone score this chapter. Because the next chapter 4 and 5, it will make you cry. Yeah, really cry if you don't understand. And I don't want you to cry. Okay, come on, guys. I think 1 minute is over. I don't care about the minutes. I just want to see the answer. But not take 1 hour lah. 1 hour. 1 hour is too long for this kind of easy question. Seriously, I will not show my answer. I just want to check your answer. If I may, I stop present right now.